Hey everyone. I just started doing this randomly, I guess. I'm recording and I'm streaming. And basically, like, my idea is I made this Tetris game last year sometime. And I was just gonna demo it, and basically the idea is to recreate it again, hopefully for some educational purposes for people that are looking to either get started with game development, or maybe they're moving on from something like Pong and Breakout and into something slightly more complex like Tetris. And I'm going to be making this in Odin, which is a language I've been using a lot. It's very C-like, and I'm going to be using a library called Raylib, which I find to be a easy library to make games with, I suppose. So I'm just going to demo this really quick so you get the idea of what we're making. I'm just going to go straight into the two-player mode. So there will be like a little thing where player 2 could join by hitting a button on the controller. Either one could press start, and then it goes into the game, and it is exactly what you would expect from a Tetris clone. Let me just show some cool stuff here. So if I go here and I'll clear a line. Actually, let me hold that. And then now I'm going to clear a line, because if you clear more than one line in two-player mode, it will send garbage over to the other side, like so. And then when this player goes down all the way, the garbage rows will come in. I know there's like some errors and things that I kind of want to clean up for this next version. So for example, I have like combo written there. I don't really know what I was thinking, because almost every Tetris I've seen has a lines field and not necessarily a combo field. And the combo would kind of intend to show how many line clears you get in a row before not getting line clears. So I already have like a lot of the art made, as you could see. It could pause, it could go back to the main menu. And yeah, really it's just to recreate this with some nice additions and some cleaning up some type of stuff that maybe I didn't know at the time or didn't know any better. So let's exit to the desktop, and the first thing that we want to do. So I guess like when I'm thinking of Tetris, the first thing I think about is the grid in Tetris. So the first thing we're going to do is draw a grid, a Tetris-like grid that we can look at and feel proud of, that we're getting closer to something Tetris-y. And I think one additional thing I want to do for this particular version of Tetris, I actually have some notes. Some goals is like make a Tetris clone, and I'm not positive. Like maybe I'll just like make it with Raylib and leave it as that. But I was also thinking about doing it like in an isolated way so that Raylib could end up being replaced with platform-specific code. Like Raylib it's like a cross-platform library. And I thought it might be cool to write it in a way where it could be replaced out. So if you want to go on and write Windows-specific, Linux-specific, Mac, or whatever specific code afterwards, that we can do that. But we'll see. Now, the first thing we just kind of want to do is draw a grid. All right, so first thing I want to do is just get a source file. We're just going to create a window, you know? So let's do that. Let's save this in the source. And I am just going to do a game file. And we're going to import Raylib. I need the package. So package, game, yep, main function. And then what do we have to do? We have to init, window, and I am going to do like a 1280 by 720 type situation here, but I will make it in a way that you can resize it at some point, and we'll get to how we're going to do that. I'm just setting it to this as now so it doesn't take up the entire screen, and we will call this Tetris EDU for Tetris Educational. If you've done Raylib before, you could probably see what we're up to here. For not, window should close, window Raylib clear background, and we will just make the background a nice black for now, because why not? Or begin drawing, or end drawing, and then after that, I think we might be good. So let's just build it and see what happens. So Odin, actually let's make a build. Let's not make a build directory right now. Odin build source, then we'll output it to tetris.exe and hope everything goes right. And there we go, we have a window to start with. That's cool. All right, so the next thing we want to do is draw a grid. So in order to draw a grid, some things we need are lines. So we will learn how to draw a line. So I'm just gonna draw a line from one end of the screen to the other, straight down the middle. In both ways, I'll draw one going down and one going across. So in between the begin drawing and end drawing, we're going to have some other stuff. So draw line, V, and it takes a start pause and an end pause. So what we could do is stuff like this. So in Odin, one common thing is that instead of having like an explicit, say, vector type or vector 2D type or something like that, you could just have an array of whatever type you want. In this case, it's float 32. So this means that there are two things, which would be the X and the Y. So we're going to draw one going across, so across, or let's just say horizontal. So this one, the X will start at 0 and the Y would be at the screen height divided by 2. So you know what, let's just start doing something like this, screen height. That's just so we could refer to it in multiple places. So this would be screen width, screen height, and then down here we're going to do a little cast to the float 32, and we're going to divide it by 2. And then the end is going to be, instead of the X being at 0, it will be at the screen width. And yep, we will also make that. Let me turn word wrap on here. It might be better. I usually don't use word wrap, but we'll turn it on for this stream. Maybe also do something like this. I think it'll be easier for people to see. So screen height, and then we still want this to be there, and we could set the color. So I'm just going to set it to white. And we will go to the terminal down here and build it again. And run it. And there we go. We have a line going across the screen. And the next thing we're going to do is just draw a line going downwards, because in order to draw the grid, we need lines going horizontally and we need lines going vertically. And draw the vertical one. So we want the mid screen going down instead of mid X, instead of mid Y. So what we're going to do is I'm just going to take this and put it there, get rid of that. And this will be screen width divided by 2 and 0. And then down here, that, and then this will be just screen height. Let's build that again and then see what happens. So let's go down here. I really need to see if there's a shortcut to just go to the terminal quickly instead of mousing on it every time. But yeah, there we go. We have a quadrant of lines going up and across. Let me just mark that vertical. All right, so what to do next? Well, I want to see, like, in Tetris, because I kind of forget how many cells are in the X direction and how many cells are in the right direction. So I'm just going to look that up. What we're going to be doing too is looking at Tetris guideline type stuff. So Tetris Wiki has a lot of good stuff, and then the Tetrio, I don't know if that's the right way to pronounce it, Tetrio, which is a web-based Tetris clone. They have a lot of useful information too. So I am going to be using that as a reference for a lot of things. So the vast majority of playfields are 10 cells wide and 20 cells, or a height of 20 cells and a width of 10 cells. So I am going to write that information down so I don't forget it. So 10 wide. And what we're essentially going to do now is just some code so we could get that grid. I want to think about where we want to start the playfield and where we want to end it, because we also want some sort of like cell size. And it looked like here that between 16 and 24 cells tall, there's a visible height of 20 cells. Okay, and like what it's saying here, this 24 cells tall, at least what I think they're saying, is because sometimes I think this is like a good picture, is that like up here there's like empty space above that might not necessarily be visible when you play the game, but the pieces are coming from above the playfield and you don't necessarily see it. So for right now, we are just going to draw the visual thing, but when we actually implement how the grid works, there will be some empty region or non-visible region above the visible playfield. So I am just going to make the cells like probably 24 by 24 for now. I don't know if that will actually be a good number, but we will change things if we need them. So cell size, and I'm going to make that 24. And what we're kind of going to do is cells width, or should we say playfield? Yeah, playfield width, and that will be 10, and then playfield height, and that will be 20. All right, so what I'm going to do is just go for the rows. So for row in 0 to playfield height, and then for column in 0 to playfield width, what we're going to do is calculate, or just start drawing lines. So for the row, we need to draw a row. So we need to draw a row here, and then we need to draw 10 columns. So let's just do that. Okay, so just going to take one of these. And I'm just going to do it in here for now. So where it would start is 0. Like I'm just going to start from the top left corner of the screen. Okay, so this row would be 0. And then this would be cell size times F32 for the given row. And I think the end would be, say playfield right side X. So this would be all the way over to the right side of the X, and that would be cell size times the playfield width. And then this will be the Y. Actually, I realize this isn't, it doesn't need to be nested. This can just, like essentially what we're going to do is draw a bunch of rows and then draw a bunch of columns. It doesn't need to be nested. I was like thinking in terms of drawing each individual cell and not like the lines that make up all the cells together. So that's what we're going to do. So first, let's see if this even works. And what I'm going to do is take this and put it in a build script so I don't have to keep going there. Boom. And we will build it with debug just in case. And I'm not messing with a builder right now, but we will soon. This REM is just kind of like commenting out a line in a batch file. And in Sublime, how you could kind of set up a build system so that you want it to run a particular like build command or build script or something is you just set up build systems in here, and then they will become exposed. So if I go to tools and developer, and then, nope, wrong. If I go to build system, and then I do this one, I'll get to this later, like what this hot reloading stuff is, but for now we're just going to use a regular build script, and it's F7, I think, by default, and something went wrong. Build takes a package as the first, so build source. Oh, this can just go over here, I think. And I think we're good. And then we will go to the terminus and run that. Okay, and that is exactly what we want for now. And I'm going to get rid of this stuff right here. So let's get, actually, let me take the vertical line again and copy it in the columns. And then we'll get rid of this because we don't necessarily need it anymore. And then what we're going to do is the same thing, but this time going across. So the X is going to also start, or this is going to be going down, sorry. So the X is going to be the column. So column times the cell size, and then it is going to start at the 0Y, and then same thing here. And then this time, well, now we need to get the playfield bottom Y, and that would be cell size times F32 playfield height. And then if we go here, we could just put it right in here. Let's run that. Panel Tetris, and there we go. So now we just need to make sure that we are drawing, like you'll see there's like empty stuff here, and I think what we want is to make sure that we draw that stuff. So first I'm going to give this a little bit of an offset so that we can see The whole grid. Okay, let's do that. So I'm also going to specify a playfield. Y'all call it playfield position? Sure, why not? And we will just set this to maybe 10 and 10, so it's a little offset from the screen start. And what we're going to do in here is that the line will start at the playfield position. Yes, playfield position X. And then I believe that this will be playfield position Y plus cell size. Let me take a sip of some tea. Let's do that. And then the playfield right side. So what we actually want to do is that the playfield right side would be the playfield position X plus the cell size. And for the playfield bottom, we want to do something similar where we have the playfield position dot Y plus that cell size. Playfield right side X, and then I think that's fine. Let's just build it and see. So we got issue. What's the issue? Build blah blah blah. Oh, the issue is just I had the executable open. That was it. And it was trying to write to the same file that was running, which is an issue. Okay, that's not right. So what we want to do is the playfield right side, oh, yes, we want to do this. Build it again, and then go here, toggle panel, Tetris. Okay, and that looks like it's starting to get better as far as like that one. So we just need to do that again. Same idea with the columns. So instead of 0 here, that's going to be playfield position dot Y. And this one is going to be the playfield position X plus that stuff. All right, let me actually clean that up a little bit. So I think this should do it. Did I set the bottom correctly? Yes. So let's, well, at least I think so. Okay, cool. So what we could see here now is, and I don't know how well this is coming up on your screen, but there is in fact lines here. Sometimes if you view it on video, because this is only 1 pixel, it may get cut off, but there is no line on this side. And we just want to make sure we draw a lines all the way around. So what we're going to do is just, instead of up to but not including these, we are just going to include them. And I think that that should do it. So now what we have is we have a grid that is, let me actually just look on the stream itself in full screen to see how it's showing up. Yeah, it looks better on the actual stream. Okay. So back to here. So now that we have that, what do we do from here? Thinking. Yeah, I mean, this is going to be a 2-player game, so I'm thinking, well, what would I do? So I think what I'm going to do now is just make it so we can start drawing in the playfield. So I guess like what I'm saying is it would be nice to come in here and be able to draw blocks in the playfield, like with our mouse cursor. And the reason for that is that once we get to a place where we are moving tetraminos around the playfield and like rotating them and whatnot, that it's really nice to be able to have like some test kind of layout for that. And I think that's what we'll do next. And this is what I would call like a debug feature. So like draw blocks in playfield, draw and erase blocks in playfield. And I hope that makes sense, why that would be a good idea. So what we're going to do in Raylib is with our mouse, we want to get the mouse position, and then we want to find out what cell are we currently in. And if you're pressing the left button down, like if it's held down, we want to draw a block there. And if there's no block there, or sorry, if we hold down with the right mouse button, then we want to erase a block there. So we need some type of way to hold information about is the block actually there or not. And we will do that like this, I think. Okay, so playfield state. The playfield state, we will just make a multi-dimensional array. We'll make a multi-dimensional array that is the playfield width and the playfield height, and it will just be a bunch of booleans for now. So let's actually make these constants. Height, and they will be booleans, and it is just set to nothing to start with. So they'll all be false. And what we want to do is, so I don't think, so I think, yeah, let's set them all to false. And then just as a test, we want to set some of them to true so that we could verify that we could draw them and see that it is working. So what we're going to do is just first set the top left to true, and then we will set the top right. So honestly, I don't know if this is a top right or top left, but I guess we will find out. So if it's rows by columns, actually changing this around, because a lot of times with like multi-dimensional arrays, typically it goes rows and then columns, as opposed to like X and Y, it goes Y and X. So if this Y is 0, this would be the top right. So we'll do playfield width -1, because that would be the index there. And then we are going to set the playfield height -1, and 0 equals true. And then the playfield height -1 and the playfield width -1 to true. And the reason I'm doing this is because what I would intend to see is I'll probably just draw like a gray or red block or something like that in the top left, the top right, this one and that one, just in a structured way, so that we can sort of verify that generally we trust that the draw logic is working, like for each of those bounds in the array. So what we're going to do is come down here, and I'm just going to say draw the blocks. And we are going to loop over, so for row in 0 through playfield height, and then for call in 0 through playfield width, we need to get like where the position is. So it's definitely going to be a rectangle, right? So equals RL rectangle. And the X is going to be the column times the cell size. And it's going to be offset by the playfield. So playfield position X plus that. And then this is going to be the Y times the row and cell size. And then the width is going to be the cell size by the cell size. So that's the block. And then I'm just going to do RL draw rectangle rec, and we're going to draw the block. And we will, yeah, we'll just make it red, I suppose, for now. Okay. And we just want to verify that that is working. Well, no, it's not, because we only want to draw them. We only want to draw them if they actually exist. So what we're going to do is say if playfield state at this row and at this column is true, then we will do this stuff like that. Panel and Tetris exe. Okay, so we could say that generally it seems like it is working decently okay. At least it seems that way. Okay, so what do we want to do next? Yeah, so we want it so that like when you click with your mouse on a particular thing, that it will set it to true or false. I am just going to do that in a separate loop, I suppose, because why not, maybe? Or should I just do it in here for now? Yeah, I think I just want to do it in a separate loop for right now. So debug set block states. And I guess the reason I'm doing this in a separate loop is that I really only want this thing to be, like, I'm not going to make it so that you can use this in the final game. And I don't think that, because even when we start getting like more of an actual play field, like as far as like the code goes, I don't think it will be too big of a deal to like do this separately. Because if I do something where if I'm like, if in debug mode, then like run this, it's easier for me to like see this in the top level of the function as opposed to like nested somewhere in there. So that's why. So what we're going to do is we're going to get the mouse position. I'm just going to call that mouse pause because we all know mouse, get mouse position. There we go. And then what we're going to do is get mouse pause rel playfield. So the mouse pause relative to the playfield, which is going to be the playfield position minus the mouse position, I think. Probably. And then what we want to do is we want to get the mouse the mouse playfield pause. And this is going to actually be 2 integers because it's going to be the row and the column. And how we kind of envision this is going to work is that it's the mouse pause relative to the playfield, the x, and it's going to be divided by the playfield width. And then we're going to do the same thing except for the y and the height. And I think this is what we'll want to do for that. And let me draw really quick, like, what is the deal with this relative to the playfield and why am I doing that stuff? So essentially, like, we have a screen, and in the game, like, we're not going to have the playfield butted up against, like, the top of the screen. What we're likely going to do is in single player mode, so here's the screen. In single player mode, we'll probably have the playfield like in the middle somewhere. And then in 2-player mode, we will probably have 2 playfields like this and this. And what we want to know is when we click, like say we click right here, is we want to know what cell are we currently in. And let's say that this starts at 10, 10, and we will say each of these blocks, for simplicity's sake right now, are 10 size. So what that means is we need to figure out what row and what column in this playfield are we in, which would be like 0, 1, 2, 3 columns. And that would be, so 0, 1, 2, 3, column 3. And we would be in row 1 because it's 0, 1. And we need the row and col so we can go into the playfield state, like this height and this width, and flip the value to what we want it to be. So in order to get the row and the column, you could think, well, if we get the mouse position, like relative to the screen, and say the x is like here. Well, let's say the x is here. And what that would be is, so this is at 10, plus 10, plus 10, plus 10, plus 5. So 10, 20, 30, 40. We'll say it's at like 45x, right? X is at 45. Well, you might know how do I get a x position down to like a row and col position when we know like the size. And really it would be like divided by the size of the cell, so size of cell, and this would give us the column, right? I think so. Maybe I'm wrong. Maybe I'm having like a brain issue, but I think that that is how you do it. You will verify. But essentially, that's all well and good, but we also have the fact that this is like offset by a certain amount. So we kind of want to move the playfield logically to be at the top right I think. I don't know. Let me just do it because I might be explaining that wrong. And I just want to verify. Okay, so we get the playfield pause, which is in rows and columns. Should we call it like 2D index pause? I don't know. Oh, I'll just call it pause. But this is really like 2D index into 2D array. And this is the call, and this is the row. Okay. So what we're going to do is in here, we're not going to draw anything. We don't need this. So if RL is mouse button down, and it would be the left button. So if that mouse button is down, we want to see if row equals mouse playfield pause Y and column equals mouse playfield pause X. What we want to do is just flip this. So the playfield state at this row and at this call equals not this. Oops. Not that. Okay, so let me build that and see if it works. It did not work. But let me just set it to true. I think that's what we actually want, not the... Oh, duh. We don't want to flip it because if you are holding it down, it's just going to keep flipping it. Like literally every frame, it's just going to flip it. So that's still not quite doing it. So if the row equals that, the playfield high equals that. Let me see if I click anywhere on this screen. Is it going to do it? Oh wait, did I build it again? Okay, so let's do something because I don't want to waste a lot of time, I guess, like just reading this code to figure out what's wrong. I mean, it's probably something very simple that I'm just missing right now. Because if this is the screen and we get it back there, does it do it anywhere on the screen? No. Okay. So what I'm going to do is I'm literally just going to draw the values of these things. I'm going to draw this. So RL draw text. I will end up like I would probably do this in a debugger if it was just me, but for right now, I just want to continue with this to show some more stuff. So let's do mouse playfield pause X text. And I am going to actually pull in the format library or FMT library in Odin. And what I'm going to do is ctprint f, and we are going to do a decimal, and we will say x equals that, and the args will be the mouse playfield pause x, and then we will do this and just do it again, except for this one for the y. And what this is doing is this is going to print out whatever this is to a C string because Raylib is a C library and it deals with C strings, not the Odin string, which is a more modern flair to the idea of strings. I guess I should say a more sane way to look at it, depending on who you're talking to. And the T means it's like temporary, so like it will allocate some memory, but it will go onto Odin's temp allocator, which actually I need to show you how to use. So at the end of our for loop here, we are going to do free all and then context temp allocator. So basically anything that we allocate during this frame that we want deallocated or cleared after the frame is done, like it's scratch kind of work, we're kind of going to just push it onto the temp allocator and then clear it at the end of the loop so that it wouldn't keep like allocating memory each frame. So now what we're going to do is draw some text, and we will draw the mouse playfield X text, and we'll place this, I don't know, I'm just going to place it at like 510. Font size will make 24, and the color will just make white. And I'm going to copy and paste that and just do sort of the same thing for this, and then we'll place this at maybe that to give us some room, and we'll see what values are getting printed out there. So okay, so that's definitely not what we want, because now they're going in the negatives. See, like, yeah, that's not what we want. So maybe it was actually, maybe it was this, I don't know. Mouse pause minus that. And so that is 0, 0, 0, 1, 0, 2. It's 23, 22, 23. It's not totally right. Well, it's not really right at all. Is that, oh, it's not divided by the width. I'm a dummy. It's divided by the cell size. Maybe that's even like, oops. Let's make that an int. This also an int. Let's put that. Okay, so that's good. And then let's toggle that and run that. So that is at 9 and 19. And that is kind of good. And if you could figure out why, well, I know why it's doing this, like why it's like immediately leaving, but we could set it. But yeah, real quick in here, is that actually what I wrote? Yeah, that was what I wrote here. Okay, so that was just a typo over here where I was like dividing by the playfield width and the playfield height, but I should have been dividing by the cell size. So I don't want this to just like reset every time. I want it to maintain. And the reason why is I am making the playfield state a local in scoped. I'm making a variable in this scope, this for loop scope, but we actually want it to be outside of that for loop. And we want this stuff to be outside of the for loop as well. Build it again, and let's run it. Okay, cool. So now we could place some blocks. And let me just do the inverse where we can clear them. So if we do this and we say if you press right, then we're going to set it to false. Do do boom 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 boom. So that It's pretty cool, right? So yeah, there we go. And that will be useful, but this should also teach like how do we go about going into, say, playfield space versus the screen space. Oh, and that'll keep getting reset because, well, we actually don't need these anymore. Okay, cool. So this kind of shows like going into screen space, into the playfield space, and how to do a transformation to get that particular value that we wanted to get. And this will come in handy when we have pieces moving around and we want to make sure that, you know, when you move against a wall, you're not allowed to move past the wall and stuff like that. So I think the next thing we are going to do, which actually, I think we're almost, I think I should probably call it soon. Because yeah, we're like at an hour. So we're going to call it. I think I will show, yeah, we're going to call it. And what will we probably do next time? So I think next time what we're going to do on day 2, or should I keep going? No, I think I will do more on day 2. Yeah, I'll do more on day 2. But what I think we want to do day 2 is we want to be able to like have the, not have, I don't know how to phrase that, but like set up different tetramino data and then be able to move tetraminos around the playfield, and then we want to be able to place tetraminos in the playfield and then I may show some nice to know debugging stuff. And I'll probably show like how to use the VS Code debugger. And I'll also show Remedy BG, which is the debugger I happen to use. And, you know, I'll also show Rad Debugger because why not? That is a cool up and coming debugger. Because you'll notice I just did everything, like any debugging stuff I did, I just kind of wrote in the game itself. But it is nice to be able to run the executable in a debugger so you could stop and look at variables and whatnot in there. So I will show some useful things. And some other stuff on the to-do, so like miscellaneous things you want to pull from, is I definitely want to show hot reloading and how you would do that. So you'll notice like a lot of times I would need to close out the app and then build it again and then come here and then run it again to open it up. So I'm going to show how you would go about implementing something where the code can get picked up by the executable. I don't know if that's that's probably not the right language to use, but essentially make code changes without needing to reopen the executable. And yeah, I think that is a miscellaneous to do I want to show. Which we'll get to someday. But yeah, that's it for today on day 1. Yeah, thank you.